how are you? I hope that you all are fine. So in this video we will discuss about resultant of two vectors. Okay. This video we will discuss about resultant of two vectors. Okay. So let's see. First, let's draw one vector. Okay. So this one is our A vector. Okay. Let this one is our B vector. Okay. And the angle between this vector is our theta. Okay. Now we will set parallel this vector. So this one is our B vector. Okay. We set parallel this vector. Okay. Now the line joining the tail of the first vector to the head of the last vector, it gives the resultant vector. Okay. A vector plus B vector. The line joining the tail of the first vector to the head of the last vector, as we know well, it gives resultant vector. Okay. Now let's say this one is our O. This line, okay. Here this one is our A, B. Okay. And now draw perpendicular OB BC. Okay. Draw perpendicular OB perpendicular BC. Okay. Now here this angle is also our theta, corresponding angle. Okay. Now this one is our OAB, but this one is our D. Okay. So here let OA is equal to and A vector. Okay. OA is equal to our A vector. Okay. And let OD is equal to B vector. Okay. Here OD vector is equal to our B vector. Okay. Now let's see from triangle. From triangle, OBC. Okay, from this triangle OBC, okay, this one is our right angle triangle. So here we can write R square is equal to this square plus this square. Okay, so here we can write OA plus AB square. Okay, here we can write OA plus OB square. Okay, plus BC square. Okay, BC square. This is our Pythagoras theorem. Okay, so here further we can write R is equal to square root. Okay, root under OA plus OB square plus BC square. Okay. this one is our equation first. Okay, I hope it's clear to all. Now let's see from triangle A B C. Okay, now let's see from triangle A B C. Okay, from this triangle. Now from triangle ABC, from triangle ABC, here we can write sin theta is equal to, as we know well, sin theta, this one is our right angle triangle. Okay, so sin theta is equal to perpendicular by hypotenuse. Okay, this one is our hypotenuse. So here we can write BC by, sin theta is equal to BC by AC. Okay, so here we can write sin theta is equal to as we know perpendicular by hypotenuse. Okay, so here BC is our perpendicular. Okay, this angle is our theta, this one is our BC is our perpendicular, and this one AC is our hypotenuse. Okay, BC by AC. So here we can write BC by AC. Okay, or we can also write BC by, this one is our B vector. Okay, so here or we can also write is equal to BC by AC is equal to B vector. Okay, okay. Now let's see here BC is equal to B sin theta. Okay, here we can write BC is equal to B sin theta. Okay, and now we can also write cos theta, as we know cos theta is equal to base by hypotenuse. Okay, so this one is our base. Okay, AB by hypotenuse, this one is our hypotenuse. Okay, AB by AC. Okay, now further we can write here cos theta is equal to, as we know, base by hypotenuse. Okay, so here we can write base by, this one is our base. Okay, AB by B. Okay, AB by AC, or we can also write B. Okay, so here we can write AB by B. Okay, further here AB is equal to B cos theta. Okay, so from here we get the value of AB. Okay, and BC. Okay, now from equation first, here we can write from equation first, from equation first, this one is our first vector, that R is equal to root under OA plus OB square plus BC square. Okay, so here we can write R vector is equal to root under OA plus OB, sorry, OA plus AB. Okay, sorry, plus AB. Okay. This one now base. Okay. So OA plus AB. Okay. OA plus AB. Okay. So this one is our first equation, that OA plus AB square plus BC. Okay. BC square. Okay. Now here OA plus AB. Here we can write OA on the place of OA. OA is equal to A. Okay. So here we can write A plus AB is equal to our B cos theta. Okay. So here we can write in the place of AB B cos theta. Okay. Cos theta. Okay. Right. Plus BC is equal to our B sin theta. Okay. So here we can write on the place of BC is our B sin theta. Clear? Here A plus B square. Okay. A square plus B square, that is B cos theta. Okay. So B cos theta square plus 2AB. Okay. So 2A in the place of B here B cos theta. Okay. Now here B sin theta square. Okay. Here we can write plus B square sin square theta. Okay. Now here root under A square plus B. Here we can write B square cos square theta. Okay. Plus B square sin square theta plus 2AB cos theta. Okay. Now further here we can write root under A square. Here B square is common. Okay. Here B square cos square theta plus sin square theta. Okay. Plus 2AB cos theta. Okay. Now here R is equal to, here we all know that sin square theta plus cos square theta is equal to, okay, this one is our formula, that sin square theta plus cos square theta is equal to 1. Okay. Now further here R is equal to A square plus B square. Okay. And in the place of cos square theta plus sin square theta is equal to 1. Okay. 2AB cos theta. Cos theta. Okay. So this one is the formula of redundancy. Okay. This one is important, that r is equal to root under a square plus b square plus 2ab cos theta. Okay. So I hope you understand this. Okay, that resulting of a vector. Okay. Now let's see. I hope to be clear. Okay. All the things. This is the formula of resultant vector. Okay, that root under a square plus b square plus 2ab cos theta. Okay. So let's see a point that if r vector is equal to a vector plus b vector, then resultant is equal to root under a square plus b square plus 2ab cos theta. Okay. And if resultant is equal to r vector is equal to a vector minus b vector, then resultant is equal to root under a square plus b square minus 2ab cos theta. Okay. So if r vector is equal to a vector plus b vector, then resultant is equal to root under a square plus b square plus 2ab cos theta. Okay. And if r vector is equal to a vector minus b vector, then we can write r resultant is equal to root under a square plus b square minus 2ab cos theta. Okay. Okay, so I hope you understand all the things. This one is an important formula, that resultant is equal to root under a square plus b square plus 2ab cos theta. Okay. And I hope you also understand this. Okay, so I hope you understand all the video. That's all for today. Thank you. Have a nice day.